Hey everybody. So we're getting into 9.3 today, looking at rhombuses, rectangles, and squares. All right. So I guess before I get into it, go ahead and get this title here and get this slide, really important stuff, and then we'll get into it. Okay, so just to kind of give you an overview of what we've been doing so far in Chapter 9. Chapter 9 is all about quadrilaterals, four-sided polygons. Okay, there's a lot of different types of quadrilaterals. The first type we learned of is parallelograms. All right, from there, we're going to kind of focus in even more and learn a few more specific types of quadrilaterals, okay, which are the rhombus, rectangles, and squares. Okay, here's the big thing. If you guys notice when you copied all of these, the first thing they say is that our rhombus is a parallelogram. Okay, a rectangle is a parallelogram. A square is a parallelogram. Wouldn't be a bad idea to underline that word parallelogram as well. Okay, the reason why is all of the rules that we just learned in the last two sections about parallelograms apply to these shapes. Okay, if you guys remember, we had opposite sides are congruent, opposite angles are congruent, consecutive angles add to 180, diagonals bisect. All of that stuff still applies to these shapes, but now, since they're even more specific, we're going to have even more rules that apply to them. Okay, so yeah, let's go ahead and take a look at these. Okay, so what is a rhombus? Okay, well, it's a parallelogram, but the thing that really defines it is that it has four congruent sides. Okay, four congruent sides. If a quadrilateral has four congruent sides, it is considered a rhombus. Okay, a rectangle is a parallelogram with four right angles. Okay, if you have a quadrilateral that has four right angles, you have a rectangle. Okay, and then over here, a square is a quadrilateral, or I guess more specifically, a parallelogram with four congruent sides and four right angles. Okay, so if something has four congruent sides and four right angles, it is considered a square. Okay, so here's the first, I guess, question I want to ask you guys. Is a square a rhombus? Is a square a rhombus? What do you think? Okay, well, for something to be considered a rhombus, it has to have four congruent sides, right? Does a square have four congruent sides? Yes. So a square is a rhombus. Okay, here's the next question I want to ask you. Is a square a rectangle? What do you think? Okay, well, for something to be considered a rectangle, it needs to have four right angles. Does a square have four right angles? Yes. So is a square a rectangle? Yes. Okay, so a square is both a rhombus and a rectangle. Okay, here's the next set of questions I want to ask you. Is a rhombus a square? Okay, what do you think? All right, here's the answer. Sometimes it could be. If a rhombus happened to have four right angles, it would be a square. Okay, so sometimes a rhombus is a square. All right, and then when it comes to a rectangle, is a rectangle a square? What do you think? Okay, again, sometimes. All right, it could be. All right, and that is if it happened to have four congruent sides, it would be a square. Okay, so that's kind of the weird thing to wrap your head around. Okay, a square is always a rhombus and a rectangle, but a rhombus is only sometimes a square, and sometimes a rectangle is a square. Okay, so that's kind of a weird thing. I just want to have you start thinking about that because that's the only thing that is kind of strange about this lesson. Okay, so let's go ahead and jump into it. Okay, so here's something, it might not be a bad idea to copy here. This is sort of an overall picture of what we've been learning. Okay, we have all of these things on the outside here, parallelograms. Okay, these are all parallelograms in here. Okay, and then we have this sort of, Venn diagram of how these overlap with one another. This is kind of what we just realized on the last slide here. Okay, but it's that squares are rectangles and rhombuses. Okay, but rhombuses are only sometimes squares and rectangles are only sometimes squares. All right, so this is maybe something worth copying down. So take a second and get this. Okay, cool. So yeah, something good to refer back to. It also has the nice little rules here. So I like this. Okay, so let's actually get into an example here. Go ahead and copy these directions and we'll figure out what they're asking. Okay, so here's what it says. For any rhombus QRST, decide whether the statement is always or sometimes true. Okay, well, first things first. Whenever they are describing a shape, let's draw that shape. All right, so rhombus QRST. So somewhere down here, draw yourself a rhombus. Usually, a rhombus, we just kind of draw like this. It doesn't need to be anything perfect. Okay, well, actually, let me see. Yeah, usually a rhombus, I guess, is kind of slanted like that. It doesn't matter. It doesn't matter. But the big thing to remember is that a rhombus has 4 congruent sides. All 4 sides are congruent to one another. Okay, which, by the way, let's name this thing QRST. I'm going to start here, QRST. Okay, big thing. This is actually really important. Make sure when you're lettering your vertices, you need to letter them in the order they're listed as you go around the shape. So I went QRST. As long as I follow that order as I go around, I'm good. You don't just want to randomly place the letters though. Okay, so here's the question. Is angle Q congruent to angle S? Always or sometimes? Okay, well, let's highlight it. Here's angle Q. Here's angle S. Okay, here's the first thing I realized. These are opposite angles. Okay, here's the next big thing to remember. Rhombuses are parallelograms, like we learned in 9.1 and 9.2. And one of the rules with parallelograms is that opposite angles are always congruent. Okay, so is angle or Q congruent to angle S? Yes. Okay, and I guess more specifically, we always. Okay. All right, so let's try with angle Q and angle R here. Let me delete this. Hold on here. I'm trying to delete just this little piece here. Let's see if I can get it. Go away. All right, so we'll just pretend that's not there. Okay, but yeah, angle Q and angle R. Let's look at those. Here's angle Q, here's angle R. Okay, are these two angles always congruent or sometimes congruent? Okay, well, here's what I noticed. They're consecutive angles. And the rule with consecutive angles is not that they are always congruent, it's that they are supplementary. They add to 180. Okay, but could they be congruent? Well, yeah, if they add to 180 and they're both 90 degrees, they would be congruent, right? Okay, so is angle Q congruent to angle R? It could be, but only sometimes. Only if they happen to both be, both be 90-degree angles. Okay, so yeah, that's the idea of these problems. I put yes here. This is bothering me because really both of the answers are necessary, are kind of yes. It's just are they always or sometimes? I'm going to erase that. Yes. Okay, always, sometimes. All right, so let's keep moving. Okay, so I'm gonna have you guys try out the same type of problem here with, we're wondering, always or sometimes, but they're asking us in the context of a rectangle. Okay, is segment FG congruent to GH? Okay, go ahead, draw yourself a rectangle, show that those segments are congruent, and tell me, is that always true or sometimes true? After you do that, go ahead and try out number 2, where they're asking, let's see, it says a quadrilateral has 4 congruent sides, 4 congruent angles. Sketch the quadrilateral and classify it. Okay, so draw the picture of this quadrilateral that they're describing and tell me what type of quadrilateral it is. Is it a rhombus? Is it a rectangle? Is it a square? Okay, so try out numbers 1 and 2. All right, so on number 1 here, first things first, drawing a rectangle. I'm just going to put it up here. Okay, so here's my generic rectangle. They're calling it EFGH. So again, I'm just going to start here. I'm going to make my way around the rectangle. All right, and here's the thing. For this thing to be considered a rectangle, if you guys remember, what a rectangle needs is just 4 right angles. Or yeah, 4 right angles. That's what we'll say. Okay, so that's what this must have to be considered a rectangle. Okay, so there it is. Now it's officially a rectangle. Okay, so here's the question. Is FG congruent to GH? Let's figure out where those are at. Here's FG, and here is GH. Okay, are those two side lengths always congruent to one another or sometimes congruent to one another? Okay, well, here's my rationale. I know that opposite sides are always congruent in parallelograms. Okay, so if we were talking about GH and FE, just these two, I would say, yeah, that is always true. Okay, but we're not talking about opposite sides. We're talking about these not opposite sides. Okay, so they're not always going to be congruent. Could they be congruent? Yeah, sure they could. They could. Okay, but it's not necessary for this thing to be called a rectangle. So this is only sometimes true. Okay, cool. Let's go down to number 2 here. It says a quadrilateral has 4 congruent sides, 4 congruent angles. Sketch it. So let's go ahead and just draw it. So 4 congruent sides, 4 congruent angles. So I'm just going to draw a generic looking quadrilateral. It doesn't matter like which way it's tipped. Okay, it doesn't matter if you drew it like a box like this. You know, that's exactly the same thing. All right. But yeah, let's see what happens. So 4 congruent sides. That is like this, 4 congruent sides. Okay, 4 congruent angles. Well, here's the thing. If all 4 angles are congruent, if you guys remember, the 4 angles of a quadrilateral always add to 360 degrees. And if they're all congruent, the same measure, they must also all be 90 degrees. 90 plus 90 plus 90 plus 90 is 360. Okay, so, you know, we could put these little arcs through like this, but let's be more specific. We know that they must be 90-degree right angles. Okay, now that we've drawn it, let's classify this thing. What is it? Well, 4 congruent sides, 4 right angles. This thing's a square. Okay, which just something to keep in mind also means that it is a rhombus and a rectangle, but that's implied when we say something's a square. Okay, keep that in mind. All right, so let's keep moving. All right, now we need to get into some specifics about the rules for these types of shapes, more specifically their diagonals. All right, so I can't quite fit all of this on the screen, so go ahead, take a minute and copy these first 2 theorems, or sometimes I call them rules. You know, if you ever hear me use the word theorem or rule, that's what I mean. Okay, so go ahead and copy those 2, get everything here, especially the pictures, and then I'll scroll down and get the third one. Okay, so real quick, also get this third one here. Okay, so let's take a look at this. It says a parallelogram is a rhombus if and only if its diagonals are perpendicular. All right, so basically when they say this, a parallelogram is a rhombus if and only if, that means this thing is required for this thing to be considered a rhombus. All right, so diagonals are perpendicular. You guys can see over here, we have our 2 diagonals. And yeah, this right angle shows that they're perpendicular. Okay, if that ever happens, we can say that, oh, this thing's a rhombus. All right, which means it would have 4 congruent sides. Okay, so rhombuses, diagonals are perpendicular. Okay, next thing, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Okay, so again, we're talking about diagonals, but now we're pointing out that the fact that diagonals are bisecting a pair of opposite angles. You know, you might want to like underline that word double, bisect. Remember, bisect means to cut into 2 congruent halves. Okay, so this angle is being cut into congruent halves, same thing over here, and then this diagonal here is cutting angle B into congruent halves, same thing with angle D. Okay, so that is something we get when we have a rhombus. All right, next theorem deals with a rectangle. Okay, let's take a look at it. It says a parallelogram is a rectangle if and only if its diagonals are congruent. Okay, and what that means is the entire length, and this is kind of hard to represent on this, but the entire length of AC, which wouldn't be a bad idea to maybe write underneath this thing, segment AC is congruent. I'll keep it color coordinated. Okay, this segment AC is congruent to segment BD. Okay, the entire length of these diagonals are congruent. Okay, so that's a few more things we know about diagonals. All right, here's a question I want to throw out to you. We had rules for rhombuses, we had rules for rectangles. Why don't, and on the next slide, I'm not going to have any rules for squares. Why don't we have any specific rules for squares? Okay, well, the reason why is because a square is a rhombus and a square is a rectangle, meaning all of these rules apply to squares. Okay, if you have a square, you have the rules, your diagonals are perpendicular, your diagonals bisect the angles, your diagonals are congruent. Okay, so just keep that in mind here. All right, so last thing we're going to do here is we're going to sketch a rectangle and we're going to list everything we know about it. All right, get those directions real quick. We'll do this together. All right, so let's go ahead and draw ourselves just a generic rectangle. So there's my generic rectangle. I guess technically not yet, okay, because, well, let's go ahead and put it. We know that for this thing to be technically considered a rectangle, it must have 4 right angles. Okay, and let's go ahead and name this thing ABCD. So ABCD. All right, and let's start making a list of the things we know. We just said one of the things. We know that a rectangle has 4 right angles. That is the definition of a rectangle. So let's go ahead and just say 4 right angles. Okay, and usually in class, this is where I would kind of ask questions around and just kind of see what you guys know about rectangles, and just sort of whittle it down to all of the little things, and you might be surprised how much we know. Okay, so I'm just going to kind of go through the things and kind of remind you and explain what we know. So yeah, it has 4 right angles. What else do we know about rectangles? Well, the thing on the, actually, we won't get into that yet. Well, we'll get to it. Let's stay on the idea of angles. Okay, we also know that since this thing is a parallelogram, which, by the way, if it's a parallelogram, that means opposite sides are parallel. Okay, let's start there. Okay, and let's show that on your shape. Okay, so it's a parallelogram. So it's a parallel. I always mess up that word. Okay, it's a parallelogram, meaning opposite sides. Well, we can maybe add that to the next one. Opposite sides parallel. Okay. All right. Well, let's stay on that theme. Going back to angles, if this thing's a parallelogram, I know opposite angles are congruent. Okay, let's add it. Opposite angles congruent. Okay. What else do I know about the angles of a parallelogram? Well, we know that consecutive angles are supplementary. They add to 180. Okay. So let's go ahead and get it. Consecutive angles supplementary. We'll just leave it as sup. Okay. Let's go back to the idea of side lengths. We know that opposite sides of a parallelogram are parallel, obviously, but we also know that opposite sides are congruent. Opposite sides congruent. Okay. Let's keep going. When it comes to the diagonals, let's go to those. The diagonals, and let's draw them in. We know that the diagonals of a parallelogram, well, the first thing we learned on this last slide was this thing. Diagonals are congruent. They're equal to one another. Okay, let's add it to the list. So diagonals congruent. Okay, what else do we know about diagonals more of a parallelogram, of any parallelogram, is that we know that they bisect one another, that this is congruent to this, and this is congruent to this. Okay, so diagonals bisect. Okay, and this is where I would kind of try to force more out of you guys, which, by the way, we let's show that the opposite sides are congruent. Let's put some more congruent bars through this. Actually, let's not. It'll start to look too crazy. What else do we know? Okay, here's something that comes to mind for me. I know that since this thing is just a quadrilateral, that the 4 angles add to 360. To 360. Okay, degrees. Right. What else? And sometimes I'm surprised by what some people will kind of remember and pull out. I'm trying to think. This is where I'm kind of taking a step back and looking and we're trying to recall if I'm missing anything. Okay. But the point is we know a lot about a rectangle. Okay. A rectangle doesn't just have four right angles. It has all of these properties. All right. So just keep that in mind. We know a lot about these now. Okay. Cool. So I'm gonna leave it there, guys. I really like this lesson. This is like one of my favorites. I don't know why. I just like the comparison of the shapes and whatnot. Okay, but yeah, I hope you enjoyed yourself, and I'll see you in class. Bye.